Volcanoes. These geological giants inspire awe and fear. They remind us of the immense power that lies within our planet. Imagine a mountain spewing molten rock, ash and gas. This is the raw, untamed energy of a volcano. Volcanoes are not random acts of destruction. They are a natural part of Earth's systems. Understanding volcanoes is crucial. They help us understand our planet's history and future. From the Hawaiian Islands to Mount Fuji, volcanoes captivate our imagination. They are a window into Earth's fiery heart. Deep beneath our feet, Earth's surface is not one solid piece. It's broken into massive plates like a giant jigsaw puzzle. These plates are always on the move, albeit very slowly. We call them tectonic plates. Where these plates collide or move apart, magma forms. Magma is molten rock found beneath the Earth's surface. The intense heat and pressure underground force this magma upwards. When magma reaches the surface, we call it lava. The lava cools and solidifies, building up over time. This process, repeated over thousands or even millions of years, forms a volcano. Not all volcanoes are created equal. They come in various shapes and sizes, each with unique characteristics. Shield volcanoes, like those in Hawaii, are broad and gently sloping. They're formed by runny lava flows that spread out over large distances. Stratovolcanoes are the classic cone-shaped volcanoes we often picture. Think Mount Fuji or Mount Rainier. These volcanoes are known for their explosive eruptions. Cinder cone volcanoes are smaller and steeper. They are built from ash and cinders ejected during eruptions. Each type of volcano provides valuable clues to the inner workings of our planet. Volcanic eruptions have shaped human history. In 79 AD, Mount Vesuvius erupted, burying the Roman cities of Pompeii and Herculaneum under ash and pumice. This event provided a chilling snapshot of life in Roman times. In 1883, the eruption of Krakatoa in Indonesia unleashed a catastrophic explosion. The sound was heard thousands of miles away, and the resulting tsunami caused widespread devastation. These events remind us of the immense power of nature and the importance of understanding volcanic hazards. Volcanic eruptions have both destructive and creative forces. They can devastate landscapes, bury cities, and even trigger tsunamis. Ash clouds from eruptions can disrupt air travel and affect global climate. But, volcanoes also play a vital role in our planet's ecosystem. Volcanic ash enriches the soil, making it fertile for agriculture. Over millions of years, volcanic activity has created new land masses and shaped continents. Section 6. Living with volcanoes, monitoring and prediction. Living near a volcano may seem daunting, but scientists are constantly working to monitor and predict eruptions. Using seismometers, they track earthquakes that often precede eruptions. Gas sensors help detect changes in volcanic gas emissions, another sign of potential activity. Ground deformation studies use GPS and satellites to monitor changes in the volcano's shape. While we can't prevent eruptions, monitoring and early warning systems can save lives and mitigate damage. Section 7. Volcanic benefits from fertile soils to geothermal energy. Volcanoes provide us with valuable resources. Geothermal energy, harnessed from the Earth's internal heat, provides a clean and sustainable energy source. Volcanic rocks and ash are used in construction materials. The fertile volcanic soils support agriculture and vibrant ecosystems. Understanding how to utilize these resources responsibly is crucial for sustainable development. Section 8. Respecting the fury volcanoes and human safety. Volcanoes are a powerful reminder of the forces that shape our planet. It is crucial to respect their potential hazards and take appropriate safety measures. If you live near a volcano, be aware of the evacuation routes and emergency plans. Stay informed about volcanic activity through official channels. By understanding and respecting volcanoes, we can coexist with these awe-inspiring geological giants. Section 9. The future of fire volcanoes in a changing world. As our planet changes, so too will volcanic activity. Climate change, for example, can influence the frequency and intensity of eruptions. Continued research and monitoring are essential to understanding these evolving dynamics. By unraveling the mysteries of volcanoes, we gain a deeper understanding of our planet and our place within its intricate systems. Volcanoes remind us of Earth's dynamism and the delicate balance of nature. By studying them, we learn not only about our planet's past, but also about its future. Gap 3S, Section 10, Volcanic Eruptions and Climate Change. While climate change can influence volcanic activity, the reverse is also true. Volcanic eruptions have a profound impact on our climate. When volcanoes erupt, they release vast amounts of ash and gases into the atmosphere, including sulfur dioxide. Gap 2S, visuals of ash clouds billowing from an erupting volcano, transitioning to satellite images of ash spreading across the globe. These ash clouds can block sunlight, leading to temporary cooling of the Earth's surface. This phenomenon, known as volcanic winter, can last for months or even years, depending on the scale of the eruption. Gap 2S, visuals of a darkened sky and a cooler, snow-covered landscape, juxtaposed with time-lapse footage of the ash settling. Volcanic aerosols, particularly sulfur dioxide, can form sulfuric acid droplets that reflect solar radiation away from Earth. This effect can contribute to significant changes in weather patterns and even reduce global temperatures. Gap 2S, visuals of a scientific team collecting and analyzing volcanic ash samples, followed by animated graphics showing the dispersal of sulfuric acid droplets in the atmosphere. However, the impact of volcanic eruptions on climate is complex and multifaceted. While they can lead to temporary cooling, the release of carbon dioxide and other greenhouse gases can also contribute to longer-term warming. Gap 2S, visuals of a balance scale, one side showing cooling effects and the other side showing warming effects, symbolizing the dual impact of volcanic activity on climate. Understanding these dual impacts helps scientists predict future climate scenarios and develop strategies to mitigate the effects of both natural and human-induced climate change. Gap 2S, visuals of scientists working on climate models and simulations, followed by hopeful images of renewable energy sources and reforestation projects. As we continue to explore the relationship between volcanic eruptions and climate change, we gain valuable insights into the intricate balance of Earth's systems. By studying these natural phenomena, we can better prepare for a future shaped by both the fiery power of volcanoes and the pressing challenges of a changing climate. Gap 3S, closing visuals of a peaceful, verdant landscape with a distant snow-capped volcano, symbolizing the ongoing harmony and tension between nature's forces. Gap 3S, Section 11. Cultural significance of volcanoes. Throughout history, volcanoes have held a profound place in the cultural and spiritual lives of many societies. For some, they are revered as gods or feared as harbingers of doom. Gap 2S. Visuals of ancient temples and shrines built near volcanoes, transitioning to indigenous ceremonies and rituals. In Hawaiian culture, the volcano goddess Pele is both creator and destroyer, embodying the dual nature of these fiery mountains. Her legend is deeply woven into the fabric of Hawaiian identity and is celebrated through chants, dances, and offerings. Gap 2S. Visuals of traditional Hawaiian hula performances and offerings made at volcanic sites, accompanied by the rhythmic beat of drums. In Japan, Mount Fuji is not just a geological feature, but a sacred symbol of endurance and beauty. It has inspired countless works of art, poetry, and pilgrimages. The annual climber's pilgrimage to its summit is both a physical and spiritual journey. Gap 2S. Visuals of ukiyo-e prints depicting Mount Fuji, followed by footage of pilgrims ascending the mountain. In ancient Rome, the eruption of Mount Vesuvius in 79 AD led to the destruction of Pompeii, but it also preserved a moment in time, offering us a unique glimpse into Roman life. The ruins of Pompeii stand as a testament to the power of volcanoes and their impact on human history. Gap 2S, visuals of the ruins of Pompeii, with artifacts and frescoes that capture daily life frozen in time. The indigenous Aymara people of the Andes consider volcanoes to be the homes of powerful spirits. Rituals and offerings to these spirits are believed to ensure the fertility of the land and the well-being of the community. Gap 2S, visuals of Aymara rituals, including offerings and dances performed near Andean volcanoes. Volcanoes also inspire awe and respect in modern societies. They are subjects of scientific study, sources of artistic inspiration, and even tourist attractions that draw people from around the world. Gap 2S, visuals of contemporary artwork inspired by volcanoes, tourists visiting volcanic sites, and scientists conducting field research. As we explore the cultural significance of volcanoes, we see how these natural wonders have shaped human history and continue to influence our lives today. They remind us of our connection to the Earth and the power of nature's forces. Gap 2AS, closing visuals of a diverse array of cultural artifacts and practices related to volcanoes, culminating in a serene sunset over an iconic volcanic landscape. Gap 3S. Join us in the next chapter as we delve deeper into the mysteries and marvels of the natural world. Gap 3S. Section 12. Cutting-edge technology in volcanic monitoring. In recent years, advancements in technology have revolutionized the way scientists monitor and predict volcanic activity. These innovations are crucial for enhancing our understanding of volcanoes and improving public safety. Gap 2S. Visuals of state-of-the-art monitoring stations equipped with modern instruments and sensors. One of the most significant advancements is the deployment of satellite technology. Satellites equipped with thermal imaging and radar systems can detect changes in volcanic activity from space. These high-resolution images allow scientists to monitor remote and inaccessible volcanoes with unprecedented accuracy. Gap 2S. Visuals of satellite images showing volcanic heat signatures and ground deformation. Ground-based sensors also play a vital role in volcanic monitoring. Seismometers, which measure ground vibrations, can detect the subtle tremors that often precede an eruption. By analyzing these seismic signals, scientists can gain insights into the movement of magma beneath the surface. Gap 2S. Visuals of seismometers installed near volcanoes with data being transmitted to a central monitoring station. Gas monitoring is another critical component of volcanic surveillance. Instruments that measure volcanic gases such as sulfur dioxide and carbon dioxide provide valuable information about magma movement and pressure changes within a volcano. These gas emissions can serve as early warning indicators of potential eruptions. Gap 2S. Visuals of scientists collecting gas samples near volcanic vents, followed by laboratory analysis. Drones have emerged as powerful tools for volcano research. Equipped with cameras and sensors, drones can safely capture high-resolution images and videos of volcanic craters, lava flows, and gas plumes. This aerial perspective allows scientists to study volcanic features in detail and assess potential hazards. Gap 2S. Visuals of drones flying over active volcanoes, capturing stunning aerial footage. In addition to these tools, advanced computer models and simulations are used to predict volcanic behavior. By inputting data from various monitoring sources, scientists can create detailed simulations of magma movement and eruption scenarios. These models help to forecast the potential impact of volcanic events and inform emergency response plans. Gap 2S. Visuals of scientists working on computers, creating and analyzing volcanic simulations. The integration of these cutting-edge technologies has significantly improved our ability to monitor and predict volcanic activity. By combining satellite data, ground-based sensors, gas measurements, drones and computer models, scientists can provide more accurate and timely warnings, potentially saving lives and minimizing damage. Gap 2S. Visuals of a coordinated team of scientists working together, followed by scenes of successful evacuation and disaster preparedness. As we continue to advance our technological capabilities, our understanding of volcanoes will only deepen, leading to greater resilience and safety for communities living in their shadow. Gap 2S. Closing visuals of modern volcanic monitoring equipment with a backdrop of a majestic volcanic landscape at sunrise. Gap 3S. Thank you for joining us on this journey through the wonders and mysteries of volcanoes. Stay tuned for more explorations into the marvels of the natural world.